So, good afternoon, and all. And today we are going to see the topic about multi-threading and the concepts of exception and multi-threading. So, let's before that we take a recall about the last session, which is threading model should be which threading model should be used. So, while you are using threading, we have to classify just single threading and multi-threading. So, while it comes to the parallelism or while it comes to concurrency, which type of threading we are going to use? So single threading means suitable for simple sequential tasks for inefficient for IO or CPU bound operations, and multi-threading improves responsiveness and resource utilization in multi-core systems. And parallelism executes tasks simultaneously on multiple cores for faster processing. So concurrency manages multiple tasks at once through time slicing. So this is the multi-threading. What is the definition of the multi-threading? Means it's the ability to execute multiple threads concurrently. Multiple threads concurrently. And the core idea of the multi-threading is threads runs independently but share resources. The benefits overview of the multi-threading is improves application responsiveness and real-world analogy like multiple chefs working in one kitchen is called multi-threading. So this is the single process P with single thread and the single process P with three threads. This is the example of the multi-threading. The advantages of a multi-threading is comes when it comes to like an umbrella. It have to improve performance, resource sharing, responsiveness, and scalability and economic. Improved performance means no method can wait for that particular resource. And resource sharing means one resource is hold by some process, the another process couldn't wait for that particular resource. And responsiveness means each and every thread allows non-blocking operations handling multiple requests simultaneously. So while it comes to scalability, easier to scale applications on multi-core hardware. In economy, creating threads is cheaper and faster than process. So this is the challenges of multi-threading, complexity, resource contention, potential for errors, debugging difficulties, synchronization, overhead. So while it comes to complexity, design, debug, and maintainability issues, and when it comes to resource contention, inefficiency due to shared resources. Potential for errors means thread starvation, priority inversion, and debugging difficulties, non-deterministic behavior, hard to reproduce. So synchronization overheads it's used to performance cost for thread safety. So this is the threads life cycle. We already discussed about the previous session. While a new thread is created, that is comes under the new state, and when it's go to the next state is runnable state. When it yield the resources, that is running state. When it comes to block, means once that particular resource is exist for that particular not available for that particular thread, which is blocked state, and once the thread instructions are over or it's not runnable, it goes to the dead state, either it is killed or dead. So this is the thread life cycle. And thread state machine means it's blocked, void, ready, running, suspended. So blocked means it's delete thread. Once it is blocked, if the particular thread is unblocked, it go to the ready state. And once it suspend that particular thread, it goes to the suspended thread. And once it's got the resources, its context switch to the running state. And if running state will take the more time, it's go to the delay thread or wait for event, then it automatically moves to the blocker stage. So this is the creating threads in Java and Python. Extends thread class override run method call start. In Python, create thread object with target function. Example code snippet is class my thread extends thread, and import threading define my function. Synchronization in multi-threading means mutual exclusion or critical section is used here. And once used synchronization or lock object means when particular thread is execute and use the resources, the other threads are wait to use that particular resource. This is locks or monitors. Mutex means mutual exclusion for critical sections. The initial state of the linked list after the removal operations, and resultant linked list. And semaphores means it's control access to a resource pool. So this is the deadlock states, and this is the thread pools, which execute a service task submitter, task queue, and thread pool. So thank you.